All right, so we're going to show that each function is the inverse of the other. So we're going to have to find f composed of g of x. And so we've identified that this is just notation, right? But we know that g of x is x plus 7 over 4, isn't it? All right, so because f is on the outside, this is the one we're going to plug into. It's what I call my skeleton, which is 4x minus 7. And what did we say we're going to plug in right there? The same thing it's in parentheses on the other side, so the x plus 7 over 4. And now I've just got to simplify this. Now, do we multiply or do we subtract first? What does PEMDAS tell us to do? We multiply, so we're going to have to work this part first. So remember, how do we multiply with fractions? Straight across. Now that first number is a whole number of 4. So how do I make 4 into a fraction?
Put it over 1.
All right. So we're going to multiply straight across, but also remember that rule that if you have something on top and bottom and they're being multiplied, it'll cancel. So notice there's a 4 on top of the first fraction and there's a 4 on bottom of the second fraction, isn't there? So they're just going to cancel each other out. If not, I would just distribute the one on top. The 4 that's on top, I should say. All right, so my 4 is canceled, so I'm just left with that x plus 7, and then I have the minus 7 there at the end. Okay, so I can now combine like terms.
Hey, what happened to the 4x plus 7 again?
1 second. And we just end up with x, which is what we were after. What was the question? I'm sorry.
You have 4 and x plus 7.
Okay. Okay, that 4 that was on top, you see how the x plus 7 is over a 4? The 4 on top and the 4 on bottom canceled each other out. So they're both gone. They canceled. Remember, 4 divided by 4 is 1, so we got rid of it. And so we ended up with just the x plus 7, and then we brought down our minus 7. And so then when we combined our like terms of 7s, they canceled, and we ended up with just x, which is what we wanted. Because the direction says it show that they are inverses. So that means we know they are inverses. So we should get x when we do their composition. Now, we've got to go the other way now. We've got to find g composed of f of x. So we know what f of x is, don't we? What is f of x? All right, and we're going to plug that into our g function. So that right there is my skeleton. And so I'm going to write out my g function, but I'm not going to put an x in it. I'm going to put parentheses there. So it says x plus 7 all divided by 4. And what are we plugging in? Yeah, whatever's in parentheses over here is what we're going to put in our parentheses on the other side. So 4x minus 7. Now, is there anything in front of the parentheses that I have on top of the fraction? No, so I really don't have to have those parentheses there, so I can just drop them. So I got 4x minus 7 plus 7 on top over 4. Remember before when we were working with fractions, we said we're going to simplify the top, simplify the bottom, and then see if we can cancel anything.
Well, the 7's cross out and the 4 cancels.
All right, one thing at a time though, okay? So first thing is we're going to simplify the top. So negative 7 plus 7 is 0, so it cancels. So we have 4x left on top over the 4 left on bottom. Then what happens to those 4s?
Cancel.
They also cancel because a 4 on top and a 4 on bottom cancels, and we get x. And that's what we wanted. So we have shown that these are inverses. You don't get just the same answer. You get x for both answers. Okay? Because a function and its inverse will undo each other so that x is all that we have left.